for help with that, I'd like to turn to our green architect, Paul Dowsett. Paul, could you tell us about a couple of the home retrofits you've done and the kind of results you've gotten?
Hey, Paul. Sure. I gotta toss it back to Greg. Thanks, Greg, for the great setup and the very kind words. So, Paul, yes, I'd be pleased to show you a couple of examples that I think tell a pretty good story. So let's just get my screen up here, and we can talk about these. So this first house that we're showing you on Queen Victoria Street, this is actually my own house, and it was an early experiment. Before I was going to tell clients of mine that, oh yeah, sure, we can retrofit your very poorly built 1914 house, as seen on the left of the screen. That's the house in the condition it was when I bought it. And you know, I took that as a challenge. I said, right, I want to energy retrofit this before I promise clients that I can do that. And with a whole bunch of strategies shown on the right-hand side of the screen, most of which you can't read here, but trust me, there were a lot of different things done with my own hands, done very economically, because as anybody who's ever bought a house knows, as soon as you buy a house, you're very poor, very suddenly. And so we did all these different things and managed to create a house that used 48% less energy than a typical Canadian home. And I thought that was a pretty significant number. Yeah. We completed this work back in 2007. It was a whole decade of work. And we also achieved a house that was cost of energy positive. Because there are 5 kilowatts of solar power on the roof, we end up being cost of energy positive. You know, we're not net zero energy, and we're not and we're not net energy positive, but we are doing pretty well. Then it turned around almost a decade later. Somebody near me had almost an identical house, just as poorly built in the first place, a little better maintained over its life, as you can see on the left. And they had seen what I did to my house, and they wanted to do similar things to their house. So again, just like my house, many strategies implemented. And on this house, we managed to achieve 83% energy reduction, lower than a typical Canadian house. Now we're really doing something significant, we thought. And this house also achieved the first Lead for Homes Platinum renovation in Toronto, which was a significant milestone. As Greg was also mentioning, he suggested I might talk about air source heat pumps. And absolutely, when we get down to a number like this of an 83% energy reduction, this house is very well air sealed. It is well insulated. It sips energy, and it is perfect for air source heat pump. And that is what is used to heat this house. So those are 2 examples, Paul.
Wow, that's amazing. What a difference. So I have to ask you, what was it that you learned in those 10 years between the first house and the second house, and what accounts for the difference?
I learned a lot of things. I think mostly what I learned was the importance of building scientists, people like Greg LeVay. I learned the importance of talking with building scientists early, with getting them to come into the house to do a home energy audit, as Greg talked about. And I think the biggest single difference in all of the work is actually air sealing. And again, this is what, hey, you got the right answer when Greg posed the question to you. The single biggest source of heat loss is air leakage through the walls, the roof, even the basement floor. So we need to concentrate on the air barrier, as Greg said. And the air barrier is a layer or a series of layers that must be carefully detailed to ensure that they are continuous around the whole house. As architects and building scientists, if we can't make it work on the drawings, then it's really unlikely that the contractor can make it work in the field. So we use what we call the red line test, and we basically trace a line over the air barrier all around the house. And if we can trace the line without lifting our pencil, then we know that it's pretty good. So that's in the design stage, the detailing stage. And then once the work has been done, nearing the end of the construction, we can actually test the air tightness before all the finishes are put on, both inside and outside. But when the contractor feels that they've established the air barrier, we can do a blower door test. So a blower door test was done in the beginning as part of the energy audit. And now we do another one here to make sure that there are no leaks in this newly established air barrier system. So we pressurize and we depressurize the house to test for outgoing and incoming leaks, because they are different. And we also do that test before the drywall is on, so that we can then seal any leaks that we find. And of course, also, as Greg mentioned, when we've achieved all this air tightness, we still need to provide fresh air. Older homes depend upon the cracks in the walls to let this fresh air in. And this is uncontrolled ventilation. But of course, we prefer controlled ventilation. So a heat recovery ventilator, or an energy recovery ventilator, HRV versus ERV, exhausts the stale air and brings in fresh air, mechanically controlled through this magic box that you see in the picture on the screen. And in the middle of that box, in that diamond-shaped thing, is where the magic really happens. So in the wintertime, the outgoing stale air is warm. It has heat from the house. The cold, fresh air coming in exchanges that heat on its way in. It takes the heat from the outgoing air and puts that heat into the fresh incoming air, and we exhaust cool, stale air. In the summertime, the opposite happens, where we would be exhausting air-conditioned air, cooled air, and what happens, and then the incoming air would be warm. So that warmth from the incoming air gets transferred to the outgoing air, and the heat stays outside the house in the summer. The difference between a heat recovery ventilator and an energy recovery is that the energy recovery also deals with humidity. So it keeps the humidity inside the house in the winter and pushes that humidity back outside the house in the summer.
Well, that's fascinating, Paul. And it looks as though you've kind of got the secret of doing this, which certainly comes out in that second house, and which has so much to do with the idea of providing a good seal and controlling the inflow and outflow of air. But I also think now about what Stuart showed us, that immense supply we have in the city, this immense stock of older homes that will have to be renovated in something like this way. Could you ever scale something like this approach to whole neighborhoods? Or is it just something, a sort of custom job for people with the money to do one house at a time?
Well, thanks, Paul. I think the honest answer is a little bit of both. Yes, we absolutely have to scale this up. We don't have the time between now and 2050 to do this one house at a time. And yet the truth of the matter is, as Greg said, every house is unique. Everyone needs a custom, bespoke, tailored solution for it. But in the city of Toronto, there are enough houses that sort of belong to archetypes, like they are similar enough that we can develop some strategies. And Stuart was talking about the scale of this in the city of Toronto, and he said that we have 422,000 homes. My number was 450,000. I will bow to Stuart, but you're going to get the math for 450,000 houses. In Toronto, with 450,000 houses, we would need to complete retrofitting 60 of those every single working day for the next 30 years. 60 sounds like a small number across the city, but we have to complete 60 every single day. and it just compounds when you then look at Ontario or Canada. In Canada, we would need to retrofit 300 homes every working day for 30 years.
That's in Ontario.
In Ontario, I'm sorry. And across Canada, we'd need to retrofit 1867, a very poetic little number, 1867 homes every working day for 30 years. This is a tremendous amount of work that needs to be done. The employment embedded into this and the material supply embedded into this is staggering. So we absolutely do need that workforce. In order to scale this, because I've been thinking about this for quite some time, we need four things, and we need four things simultaneously. They all have to exist at the same time. We need ready homeowners. We need homeowners who are ready to make this investment and disruption in their homes. So they need to be convinced that this is the right thing to do. And that's what a group of us are doing right now, that we have to do the convincing of the homeowners first. We also need a ready workforce. We need a workforce that knows what to do and is ready to do the work that needs to be done to all these houses. So there's another group I'm involved with that is actually developing the curriculum to train the workforce to do the work necessary. We also need a ready supply of materials, all those air barrier systems, all that insulation, all that new cladding on the outside of houses. We need all that material ready so that in the city of Toronto, we can complete 60 houses every working day. And of course, we need a ready method to pay for the work. That's the other thing that we need to have on hand, because homeowners won't be ready and the workforce won't be ready and the suppliers won't be ready if they are not all simultaneously convinced that there's a way to pay for all of this. So it's a classic chicken and egg problem. Every one of these four elements is needed simultaneously to enable the other three. So that's some of the scale of what needs to be done in order to make this a community-based or larger than one house at a time.
Well, it sounds like maybe the biggest challenge of those four would be getting homeowners ready to take this on. And it sounds like you're doing something along that line. Maybe you could tell us a little bit about what that is and how it's going.
Absolutely, Paul. So I live in a neighborhood in the city that's known as the Pocket. We're at the eastern edge of Riverdale in the east side of the city. And within the Pocket, we have a project that we've been working on for 4 years called the Pocket Change Project. And what we're looking to do is we are looking to make our community, our long range goal is to make our community net zero carbon. And we want to do that by 2050 in lockstep with the city's plans. And the Pocket Change Project is possible to contemplate because we've spent the last 20 years doing community building in our neighborhood. And because of that, in our neighborhood, we have many, many shared values to build upon, and those are listed on the slide here. We have a lot of socially conscious people. We're very welcoming. People very much want to partake in opportunities to make the Pocket a better place to live. Everybody has a great community spirit. And if you're living in a community that is not yet built and developed, hasn't done this community building and sharing of values, maybe not worry. As the old adage says, the best time to plant a tree is 20 years ago, and the second best time to plant a tree is today. So I'm saying to everybody who's listening in tonight, start your community building now. If you didn't start it 20 years ago, well, start today. That's second best. And those two houses that I showed you at the beginning, my house is in the Pocket. The other one is very near the Pocket. And these and a number of other houses that our firm has worked on really serve as examples to the people in the Pocket of what can be done. And so we're starting at the grassroots community level. to help our neighbors to understand why home energy retrofits are necessary, how they can be accomplished, who can do the work, and what financial help is available. So we're starting that work right now. Well, we actually started almost 4 years ago, but we're ramping it up right now to make sure that the push the push is really on with the neighbors to get this going. And overall, there are 3 major steps in our Pocket Change project. The first is to raise awareness and inspire action. And of course, that's exactly what we're doing right now. We're at the beginning. Once we've passed step 1, we then want to actually get our neighbors to take action to conserve energy in order to reduce their greenhouse gas or their carbon emissions. And then this will allow us to switch to renewable energy. This will then, once we've done the work, once we retrofit the homes, once we've improved their air tightness, improved their insulation, then we can switch to renewable energy. Then we can switch to those air source heat pumps, as were talked about earlier. And all of this is to create a sustainable community here in the Pocket. All along, we're working towards to be as sustainable as we can. In the next 30 years, we'll also be greening our transportation. We'll be greening our food sources to the Pocket, trying to really localize our food sources, and looking at many, many other aspects of our daily lives to create this totally sustainable community. Because we as a community want to do our part to help the city, to help the province, to help our great country of Canada, to all do their part. And we figure that because we started 4 years ago, we're out there in front, and we know that there's a tremendous responsibility there, that all of our learnings, both positive and negative, I'm sure we will have negative learnings, all of our learnings we're going to share with everybody else across the city, the province, the country. So thanks for asking those questions, Paul.
Well, thank you so much, Paul. That's absolutely fascinating, and I'm sure there will be lots of folks who will be interested in seeing how they can apply what you've learned to their own neighborhoods as well. You know, when I think about it, doing home energy renos as part of a community just seems to make so much sense. And it seems a lot easier than having to go it alone. If you weren't sure about something, you could always get help from your neighbors.